Hi guys, welcome to Terminal Coders. This is my second video tutorial on buffer overflow. I hope you have watched the previous tutorial. Else, please visit my blog Terminal Coders. Okay, www.terminalcoders.blogspot.com. This is my blog, and you can find some useful tutorials, and this is my first video. I hope you will you have watched this, else you first watch this video before going to second. Okay, yeah. Mm, Make a new directory called new to store our new exploit. Store our exploit here. Okay, let's start from theory. First of all, we can look the 32-bit architecture. So in 32-bit architecture, we can find these registers. EAX register is an accumulator register, and EBX register is base register, ECS register is counter register, EDX register data register, EDI register destination index register, ESI register source index registers. These are index registers, and these four are general purpose registers. General purpose registers are used to general purposes like storing variables, etc. Okay, next is pointer registers, that is EIP instruction pointer register, ESP stack pointer register, and EBP base pointer register. So the important registers in buffer overflow attack are EIP, ESP, and EBX. So what is EIP register? The EIP register is instruction pointer register. So it stores the next address of next instruction to be executed. So what is in the uh, so there may be an address in EIP, and after executing current instruction, the CPU will load the instruction at the EIP instruction stored at the address of EIP register. So this can, after taking the CPU instruction, the EIP will change it to next instruction, address of next instruction, and this is the cycle, instruction execution cycle. Sorry, not instruction, program execution cycle. I hope you will study this in computer organization. Okay, these are theory parts. Next is ESP register. ESP is stack pointer register, and EBX register is base register. Let's look the article before. I have to say, what is the task of buffer? What is the task in buffer overflow attack? Simply, the main task in buffer overflow attack is rewrite the contents in EIP register with some address which points to the um, evil instructions, which points to evil instructions which we want to execute. So rewrite the contents in EIP register with the predefined address, and it calls execution of our evil code or evil instructions. Okay, let's look the stack. because we are discussing about stack buffer overflow. Okay, this assume this is stack, and this is bottom of stack. This is the top of stack. Okay, but, don't understand. This is top of stack because this is the size. We can push something up to here. That's all. The top of stack is, and so if the stack is empty, the EBX and ESP points to same address. That is the bottom of stack, right? Sorry, and sorry, not sorry. Okay, next I am going to push something into stack. This is I am going to push. Now the ESP will increment and points to here. Yeah, and pushing something into it cycling. Now the ESP will change points to here. Yeah, it will point to here, and pushing something again. Now the ESP points to here. The reverse will happen when pop instruction. So okay, the pop instruction and ESP decrement to here. So always the function of ESP to point the top of stack. This is the top of stack. Okay, let's start exploit programming. We can exploit the buffer overflow in two ways, using ESP and using EBP. First method, I'm going to show the first method. I am using Python to exploit code exploit, and new file. I call this file as esp new esp.py. Okay, just copy the previous exploit from here because I hope you watched the previous tutorial. Yeah. So our task is rewrite the EIP with the instruction called JMP ESP. So we want to rewrite the contents of EIP with the address of JMP ESP. Okay, immunity debugger. Yeah, I'm using immunity debugger to exploit and run. Yeah, I am running our program code player. This is our target program, and run. Okay, open. Next, watch executable modules. I assume the Instruction JMB ESB will be in user territory DLL. Let's search Ctrl plus F JMB ESB. Fine. Yeah, I got it from here. Copy and paste here. Sorry. Okay. We want to rewrite the tenants of EIP with the address of JMB ESP instruction. This address and this is the instruction. Write the instruction in big endian mode, that is in a reverse manner. 53 is going to first, 93 second, and go on. 93 slash x, 42 backslash 7e. Okay, if we override the EIP with the address of JMB ESP, it means the next instruction to be executed will be after the ESP. That means we want to write our evil code here, from here to here. Okay, I'm going to write evil here. Okay, I am writing evil code here. It is not we don't want to fill our stack with evil code, so we want to write our evil code from here until we can write our evil code until we reach the limit of the stack. So we can write evil code here too, and we cannot add furthermore evil code because we exceed our stack. Okay, let's look. So now the instruction is passed here to so this is we want to fill here with some junk codes. That means I have made junk code, and it goes junk code goes filling the stack, and if after junk, if we add something more, it goes stack buffer overflow and rewrite the EIP with the something after the junk. That means we want to write EIP here. So from here this code will cause rewrite the EIP with the instruction JMB ESP. So next I want to write 25 knobs. What is actually knobs is a simple instruction which calls the CPU to sleep. That means keep in ideal state, and the CPU do not do anything and keep in an idle mode. So at that time we can load buff into memory. Okay, this is our exploit, and going to create okay, open new directory, and create esp.m3u. Run. The total size is 506. We can write 512 bytes in the stack. Okay, done. Let's run our target application and load our exploit. our evil M3U file. I'm going to open. Let's look what happened. Oh my god, something happened. What happened? Let's look at the code. Oh my god, I forgot to write X here. Okay, again run. Sorry, this is a big mistake, and so that it didn't get to the result. Okay, load. Successfully. One more we can look. Code and run code. Our chunk is size 253, so I have write on 253 bytes and as a chunk, and added EIP. That means the address of instruction JMBSP, and these two strings causes overriding of EIP. So next we want to write some knobs. That means to keep the system ideal, and after that is said, we want to execute our buff. That means our evil code, shell code. This is a shell code which will open the calculator. Okay, run this. Running. Sorry. Our exploit is here. Watch. Okay, load. Press L to open. New. ESP. Wow. Done. And watch a second method, that is how you exploit using EBX. This is the same method, and we want to rewrite EAP with the JMP EPX. So our evil core, it is here. So after rewriting the EIP with the address of JMP EBX, the processor execute the instruction just after EBX. Okay, these are instructions, our evil instructions found after EBX. So rewrite our exploit. One more. Okay. Copy the same code to new file and save it as epx.py. Oh, sorry. Oh my god. Rename it. epx.py. Delete this and delete this. Okay, let's check the size of knobs plus L buff. Print the ln of knobs plus buff. Run. 246. 247. This I'm going to create ebx.m3o. Okay. Once again, the forward size is 248. So I want to find how many buffs to add to this code. 253 minus 248 plus 25. Now we have 25 buffs, and I want to add for 30. And now watch. Length of buff 253. Length of knobs plus buff is equal to the chunk, and delete the chunk. We don't need any chunk here. Okay, knobs plus buff. Knobs plus buff plus EIP. Okay. Yeah, write our exploit code here. Let us run. Save 253. Okay, EBX. We have created our evil M3U file. Alright, open. Our codes are stored in new, and EBX is created in the second method. Open. Oh, something. Oh my god. We didn't edit this with the address of JMB EBX. Let's find the instruction JMB EBX view executable modules system32 kernel plus F JMB EBX. No, JMB EBX is not found here. Check again another dealer. Find kernel plus F JMB EBX. Done. We found it here, and copy this here. Okay, write the address in a big endian. I'm writing first X because I forgot this in previous. 8002 B2 7C. Again, I'm running the same size. New EPX. Wow, we have exploited the same vulnerability in the second method. Okay, we done in both methods using EBP and EBX. I hope you understand what happened here, and I'm going to shut down my VirtualBox. Okay, I hope you understand the two methods, and I'm sorry for screaming in this audio because got some problems in headset. And again, sorry for my bad English. Log out. Terminal codes.